William Solecki is the director of the City University of New York and their Institute for Sustainable Cities. He's also a professor of geography at Hunter College. His research focuses on urban environmental change and transition, specifically climate change and cities. He has been an author of the Intergovernmental Panel on Climate Change 4th Assessment Report, and he's also now on the IPCC's 5th Assessment Report. And he was a member of the Scientific Steering Committee of International Human Dimension Program on Global Environmental Change, the Urbanization and Global Environmental Change Core Project, and a panel member on the U.S. National Research Council committees. He's a co-founder of the Urban Climate Change Research Network, co-editor of the recent Climate Change and Cities Assessment Report. If you haven't picked up on it yet, this guy really knows what he's talking about when it comes to climate change adaptation. He's also co-leader of several climate change impact studies in the greater New York and New Jersey region, and in fact was a co-chair and co-editor of a report that was just released yesterday called the Climate Risk Information Report. This was a New York City panel on adaptation that informed a second report that was released yesterday, the Special Initiative on Rebuilding and Resiliency Report, which was released by the City of New York yesterday, as I mentioned, and if you looked at the New York Times today, it was above the fold, so you might have had a quick introduction to this. Dr. Solecki received his bachelor's degree in geography from Columbia University and a master's and Ph.D. from Rutgers University in the same discipline. I'm very honored to welcome him here today to talk with you about climate change adaptation.
Okay, well, thank you so much. Thank you for inviting me to sort of say a few words about some of the work that we've been doing in New York. And it's always very special to chat with folks from the press and all that kind of good stuff. I've done some of that, and the standard line, among scientists in terms of talking with the press, and this is sort of germane to the maybe the New York Times or other similar publications. The metric is like, do you get it on like the metro page? There used to be a separate metro section, or like an intersection. Is it, of course, below the fold or on top of the fold? Is it front page or not? And then, of course, the other way is like, is it on front page, above the fold? And then, of course, is the right column or left column? So today, the New York Times front page, above the fold, on the right column, was Bloomberg's plan, the $20 billion that he was going to spend on, or thinking about spending, with respect to climate change, sort of resiliency with respect to Hurricane Sandy, and what to do in the aftermath of Hurricane Sandy. So that's, as was mentioned, I had a role to play in that process. I was yesterday at the there was a greenhouse in Brooklyn Navy Yard. There was hundreds of folks there. They were assembled to hear this address. I was there. It was very interesting. It was sort of an interesting statement of the mayor, who was sort of well honored for his work in the aftermath of Hurricane Sandy, but also sort of putting forward this huge tome of a report that was about 430 pages of text, looking at how what actions the city should take in response to Hurricane Sandy and how to spend about $20 billion worth of cash. So it was sort of a very interesting moment, because it was also the sense of winding down. Right? The Bloomberg administration has brought forward a lot of initiatives on a broad range of sustainability issues, promoting resiliency within the city, but also looking at questions of climate change adaptation. So what I want to do today is sort of highlight a little bit of what has just happened in the last 24 to 48 hours with respect to some of the public release of these documents, but also sort of look a little bit into that process of resiliency, and how do you make cities resilient, and what is some of the science behind that. So I'll try to sort of detail some of that in terms of lessons learned moving forward. I think the interesting thing to think about as we sort of step into this a little bit more formally is that Hurricane Sandy was struck in late October of 2012, had a significant impact, certainly in terms of lives lost and lives disrupted and level of damage and the rest. And one of the big questions has come up is, well, what does this mean in terms of moving forward? Is the response to Sandy going to be somewhat similar to the response to Hurricane Katrina? Now, Katrina also was a devastating event by many metrics, worse, although maybe Cuomo, governor of New York, thinks Sandy was just as bad. Got into that little struggle, whose disaster was worse. But anyway, the problem with Katrina, the issue with Katrina, was with respect to climate change, and the issue that I'm sort of focused on here and sort of more generally, is that Katrina, the recovery of Katrina, really did not involve a response to the question of climate change and how do you create cities that not only need to respond to extreme events, which are part of the process of what cities do, but also recognizing that cities are in sort of this interesting dynamic where the environment in which they are present is changing. So that they have to sort of not only recover from the past event, but also sort of try to create a situation where they're fitting their development strategy to a future world. So when the rebuilding of Katrina took place, and the rebuilding of the levees, et cetera, they didn't take into account in any real meaningful way, as far as I understand, sea level rise. So recognizing that we have a situation with global warming and accelerated sea level rise, that these large-scale infrastructure features would become less useful in the decades to come. And of course, this is even playing out locally. It's interesting. I know someone was mentioned from New Jersey. I live in New Jersey, so I can sort of bash the governor and the state a little bit. I mean, the Christie of the state of New Jersey, I don't feel has been nearly as aggressive in some ways with respect to responding to some of the questions of climate change. And so it's going to be very interesting to see how this trajectory of redevelopment takes place, comparing what happens in New Jersey, the process that's unfolding, and what's happening in the state of New York and the city of New York. At the moment, what we see for the city of New York is that in some ways the statement that was put forward yesterday is a bold plan, is an innovative plan. I wouldn't say it's perfect, but it sort of does speak to that issue of resilience and how to sort of create a more resilient city that is now in this sort of dynamic environmental context, meaning that the environmental baseline of the city is changing. So I'm just going to go through some slides. I'm going to talk a little bit about some of the work that I've done specifically with respect to this. There'll be some data, and then I'll turn a little bit more to the plan generally that was put forward yesterday to sort of talk about some of the elements. Probably you've all been familiar with that over the last 24 hours if you've looked at some of the news feeds and so forth. I don't want to go too much into that, but then I'll try to provide a little context of like how to think about some of these questions moving forward. So this was the plan that was released. It was released yesterday. So the organizers of this conference knew that they needed to invite me today rather than yesterday or the day before this event, because I wouldn't be able to speak about these things. But now that it's happened, now that it's been released, it now is something we can talk about. All right. So it was a huge effort, which I can go through in a moment. And this issue of resilience, I really didn't actually see pieces of this report that was produced yesterday, this special initiative. I contributed to one chapter of that report, and then little bits and pieces. The science that we contributed was actually, I like to say, underpinning a lot of it, but also was sprinkled throughout. But this issue of resilience, I thought I liked. It's probably way too small. It's actually a little small for me to read on the screen here. But let me see if I can do it. It's really kind of cute in a way. So resilient. So this is like the preface, right? Able to bounce back after change or austerity, capable of preparing, responding to change. It's basically that classic resilience notion, more of an engineering quality than anything else. And then, of course, they have a synonym, tough, right? And then see also New York City. Isn't that cute, right? So that's the essence of it, and this was dedicated to the folks that unfortunately lost their lives with respect to the storm. But it's that sort of counterweight of the idea of resilience, tough New Yorkers. That's I don't know how many times Bloomberg said that yesterday, but the idea of sort of moving forward even in a moment of loss. So Hurricane Sandy, as we know, was a huge event. By many sort of metrics, a very unusual event. We can sort of look into the science as to whether or not it was aided or contributed or driven by climate change. Of course, that's difficult to sort of, you all recognize that you can't really attribute any specific event to climate change, but you can say that some events are reflective or emblematic of the conditions under which we would expect climate change to occur, standard line. There were several conditions that you could say that resulted in a greater impact from Hurricane Sandy, particularly things like sea level rise. We recognize that the sea levels in and around New York have been rising about 1 inch per decade in the past century, and that about 60% of that has an anthropogenic or a human-caused signal to it, while about 40% or so has a natural quality. So we can recognize that already that's an important measure. There are other things. The waters were warmer off of the North Atlantic, which sort of gave it a little extra juice and a little extra punch. Even the directionality, that sort of weird dogleg to the left that took place. Some of the cutting-edge science is speaking to the fact that there might be, because of Arctic sea ice loss, and particularly in the summer months and in through the early fall, that we're having increasing variability in the jet stream and a deeper plunge of the jet stream, very similar to what we saw for Hurricane Sandy. And it's then that deeper plunge that creates wind conditions to drag events that normally would head off to the east, which has been the prevailing situation, but in some cases maybe do the dogleg to the west. So that was part of the interesting element. That's more speculative as to whether or not that's connected to climate change. There were a lot of very unusual events sort of that connected Sandy with respect to its impact and whether or not it's climate change. But that's another part of the story. We know that there was a lot of significant impact of the region. And I also I clipped some of the slides that Bloomberg showed yesterday. So this is one of the images, sort of that notion of the blackout. And this is where this issue of climate change and impact really plays out in a very sort of delicate and really a measure of inches. I mean, this is Lower Manhattan, obviously. You see the Empire State Building in the distance. And we recognize that, you know, there was that Con Ed substation that went out. Well, you know, guess what? I mean, the Con Ed substation, they knew about potential storm surge. They had a storm surge protection wall around the critical facility. It was just too low, right? It was at, you know, the previous storm of record over the past 50 years. It was a little bit higher than with the storm of record in the early 1960s. But this particular storm surge was about 2 feet higher. So if that wall had been 2 feet higher, 24 inches, all of Lower Manhattan, you know, I can't say it wouldn't have gone out, but it wouldn't have gone out because of that particular power loss. And it could have been a very different story. So there are all these sort of little examples of sort of, you know, vulnerabilities that were exposed. But I think it raises that sort of, you know, larger question, well, what does this really mean? Okay, what did Hurricane Sandy really mean? We knew that New York, you know, was, is, and will be vulnerable to storm surge events of this type. I mean, the Office of Emergency Management in the City of New York plans for even worse storm surges, where you could have 20 to 25 feet in worst case scenario. That's what they're basically planning for, in worst case scenario. And we know that second only to Miami, it has the greatest amount of value of assets sort of at the water's edge in the high-risk zone, and of course, you know, similar number of population at risk in terms of in the flooding zone, and that number has actually just changed in the last few days, which I'll go to in a moment. So, of course, the question comes up: what does this reveal about the issue of exposure, vulnerability? What does it mean about the connection between disaster risk reduction and climate change adaptation? This is sort of this issue that I mentioned. I mean, there were always cities are about creating safe zones for residents. I mean, the walls of Jericho or the medieval, you know, gated cities and so forth, they're all about creating protection for residents, right? Even in the 20th century, a lot of it was, you know, how to protect our air, our water, the things that we live with every day, right? And so we recognize that disaster risk reduction is part of that history as well, but now we have to sort of blend that in with this notion of climate climate change adaptation and climate risk preparation. So, and one of the questions that I ask, does the response to Sandy signal a change in policy? Is there a sort of a tipping point or transition in policy? So these are questions that we can ask, and I think we can only sort of answer them over time, and maybe we can look at this particular event and try to understand how is it sort of benchmarking, and what is the Hurricane Sandy and the response in this sort of interplay between moving toward greater adaptation and an incorporation of climate science into our everyday practice. And so we see this is an elevation map showing it's probably obviously too small for the legend and so forth, but the brighter the green, the lower the elevation, right? So this is a city that's very much at the water's edge. And of course, if we look at the inundation zone from Sandy, we recognize that large chunks of lower Brooklyn and Queens, and of course many of the other boroughs, all the other boroughs were inundated as well. It's just a little snapshot. So as I sort of highlighted this notion of disaster risk reduction, oftentimes there's a sense of, okay, an event happens, we have to prepare for that event, or sort of prepare for it, respond to it, and recover from it. And oftentimes we look, at that event, and of course the cliche is we don't want to recover to the past event, but in many times we do, right? But then also we want to look at sort of the past record of events and sort of see how it all fits together, right? That's the classic sort of model. But I think one of the things that's starting to happen with Sandy is that Sandy, as an extreme event, as a single event, is now started to be embedded in this larger discussion, this larger narrative of climate change. So it's sort of like this chronic condition of climate change with these sort of punctuated extreme events. And of course, the flip side of that is that these extreme events sometimes become the avenues or the policy windows through which there could be real meaningful policy change. Right? And so the question now remains, is this report that's come out, part of a signal of policy change, or will it be sort of a long-standing, will that report sort of retreat into the distance, and you won't see any significant change? So I think that it's really crucial then to sort of look at this idea of recognizing that cities, the environmental baseline of cities are changing. And so that as cities recover from extreme events, there's this new tension or new issue they have to deal with. It's not just the past event or the past series of events, but they have to try to sort of project out how to prepare for not only those events that have passed, but events that might occur in the future, which could be accelerated, become more intense, or more impactful than in previous situations. The classic example, of course, is sea level rise. Hurricane Sandy occurring, we know that the base rate of sea level rise for the city of New York is about 1 inch per decade, right? So we know, just even if you extrapolate current trend, that if Hurricane Sandy occurred, a few decades from now, there'd be that much more additional water around. So if we think about sort of vertical rises, let's say in a decade it's been about that much, right? Well, that doesn't seem like very much, but recognize that vertical rise might relate to some horizontal rise of inland movement of water, right? Again, recognizing that this is a slope as that water sort of creeps up. In the kind of illustrating that a little bit more, it's interesting. Yesterday, I wasn't able to sort of get out and about with the disaster with Hurricane Sandy, but I was on Water Street yesterday, and that was sort of the edge of where the water came up. And of course, the cliche, Water Street used to be the edge of the island of Manhattan. That's where the water of Sandy came up to, roughly around the intersection of Water and Wall during the evening of Monday, the 29th of October. Now, the thing that is significant there, if you stand on that spot and you imagine, well, just imagine there's going to be another foot of water, or 2 feet of water, or 3 feet of water, at any point in the future. So you translate that horizontally, that means that water is going to go further inland. And so with each foot that it moves inland, the possibility of damage or other sort of injury increases. And what that then translates to is increased losses, right? So, I mean, just one little tidbit. Like along Water Street, along the East River there, many of the buildings lost significant amounts of their infrastructure or was damaged. And it's now estimated that each building to rehab it is going to cost about $100 million. There's about 15 buildings right in a row, right? So that's $1.5 billion right there. Now, if you have forward movement of water up into Wall Street, obviously, any building that's taken out and a significant loss of infrastructure, you can imagine, the old cliche, 100 million here, 100 million there, pretty soon you're talking real money. And so there's a lot of damage potential. So that's the issues that cities have to deal with, this idea of dynamic climate change. Now, what I want to do is sort of specifically reference the report. I'm the co-chair of the New York City Panel on Climate Change. This is the report that we released yesterday. And if you want to see it, there's lots of different places, but it's available on the Institute website that I direct, CUNYSustainableCities.org. Maybe too small to see in the back. I'm sorry about that. Or you can just Google it. I'm sure it'll pop up. But what this report attempted to do, and what our mandate was part of the New York City Panel on Climate Change, was to provide updated climate risk information for the city. And that this information was then integrated into its long-term planning capabilities that was part of the special initiative which I mentioned. So I'm going to go through some numbers. I don't want to, I'm realizing I'm looking at my little, it has all this information here, it has the elapsed time, so I'm realizing I'm babbling on. So I don't want to take up too much more time with respect to some of these details. But I'll go through some of the numbers, give you a flavor of what it tries to present, and then I'll talk a little bit about the SIR as well, and some of the other sort of contextual ways to think about it. So this is like the grist of the data, and you know, I'm looking at the audience and sort of the size of the slides. It's too small. But one of the things that we tried to sort of present here was various sort of bits of information about how future climate change will play out in the city of New York. So this is baseline climate and mean annual changes. So we looked at temperature questions, precipitation, as well as sea level rise. And basically and this was something that we had done in 2009. The city had asked us after Sandy in January to redo it, to redo the numbers, rerun the numbers, and see how they're playing out now. And what we find is that there's some acceleration. It's not a dramatically different story, but there's some different story. So for example, we know that you know, from about 1900 to about 2010, the temperature for the city of New York, on average, increased by 4 degrees Fahrenheit, as example. Not trivial. And that's somewhat corrected for urban heat island. Some people might think technically along those lines. But, you know, in the next, and not to get too fine-grained into the modeling here, but we used a base period of 71 to 2000. We find that that rate could maybe go up by about 50%. So instead of well, 1 inch, over the course of the decades, about 4 degrees. So by the 2020s, as an average decadal slice, we could see 2 to 3 inches of increased warming on an annual basis. For the 2050s, again, too small for you guys to see, I'm sorry about this, maybe about 4 to 5.5 degrees Fahrenheit. All right? So it gives you a sense of an increasingly dynamic and sort of accelerated process. The thing that the city was most interested in, which I'll highlight back, we can go through all these numbers in little ways, but it was the sea level rise. Again, there was an expectation of about 1 inch per decade, or sorry, there's an observed case about 1 inch per decade for the 20th century. That number could go up several times by the 2050s. So by the 2050s, in sort of the upper case example, we could have 31 inches, you know, of additional, about 2.5 feet, rather than the 10 feet. So, you know, about 3 times that rate that we've seen over the past century. Now, I don't want to go too much. We didn't necessarily do the modeling out for the 2080s or to 2100. But one of the things that we see is that that rate of increase could potentially accelerate further as the decades move along. So this is some of the information that was provided. It's this the red barred area that was particularly of interest to the city, because this is really the focus of the SIR. We also presented a lot of information about flood periodicities. And I don't want to go too much into this, again, because it's sort of small and most can't read it. But it's quantitative changes in extreme events. And what we tried to do is to highlight what the city is most concerned about 4 types of extreme climate risks. So it's not just how much the temperature is changing or how much the precipitation is changing. They want to know, what's the change in heat waves? How many more heat waves is the city going to get? They want to know, what is the change of heavy downpours, heavy inundation, things that sort of close the subways down or cause increased turbulence and problems with the water supply system. They want to know what is the change in high wind events, because that could mean a lot of devastating loss of a range of things, but, you know, obviously blowing out of windows as an example. They also want to know about storm surge and the frequency of storm surge, and how often are we going to get this 1% flood again. So one of the things that is important to sort of recognize and conceptualize is there's sort of two elements of this coin, right? The notion of the 1% flood, or the 1 in 100 year flood zone. What that is saying is it's that area that the Federal Emergency Management Agency expects to be flooded with a 1% chance of any one particular year. Right? It doesn't mean that it happens once every 100 years, but it's a 1% chance each year. What we recognize is, again, two things will happen. One is with sea level rise, you're going to get more events that are going to reach that threshold simply because there's a higher baseline. Right? Think of a bathtub, like it's half full. You know, if you have a little kid or somebody, a toddler, sort of like splashing around, it's not going to fall out of the, it's not going to splash over the tub. You put another 4 inches of water toward the lip of the tub, the child is sort of splashing around, it's going to splash over. You're raising the baseline, so you're going to get more frequently that kind of extreme event. Conversely, if you do get a really large-scale event, it's going to be that much more damaging because you have that much more water available. All right, so that's sort of a couple of the tension points that are present. Now, this other slide is way, way too small, but basically you can go to the videotape or go to the report. But basically what we tried to do is to look at that question of a range of other kinds of extreme risks. Now, I'll give you a technical element here. This first slide relates to sort of model-based data outputs. So what we did is look at a defined baseline period of the data record and then applied a series of climate models under different scenarios and then grouped them together and tried to create a range of model outputs. Right? So it's very much directly model driven. With each successive slide, these become more interpretive, meaning that we're taking that model output and then putting it into a secondary model, let's say a sea level rise model, or deriving sort of qualitative statements about what we could assume based on the model output. And it's this slide in particular that sort of highlights that point. And again, too small, but it talks about things like, are we going to get more hurricanes? Are we going to get more intense hurricanes? Are we going to get more nor'easters? Are we going to get more large-scale snow events? Are we going to get more downpours? Things that are with respect to modeling, are much more problematic to define for a variety of reasons. So the short version here, of course, is that it's still unclear, and what we use are sort of various sort of statements, but it's still unclear as to whether or not there will be more frequent hurricanes. It seems logical, because you're sort of kicking up the system. But what seems to be increasingly evident in the literature, both in terms of some of the model outputs and some of the interpretive qualities that go on, is that we will get more intense hurricanes. All right? So that's something that's felt to be well understood. The other question is, will there be more nor'easters? Of course, that's something relevant for New England as well, very much so. It's still very difficult to say. Right? It makes sense, but we're not sure. Right? The other thing that's sort of another metric that is oftentimes used is this notion of heat waves. One of the things that sort of played out in this process is that while most of it is focused on the coastal zone and some of the areas associated with protecting life and property in the coastal zone, the city is very much concerned about heat. Heat, as you probably know, nationally and on a year-by-year basis is one of the most leads to the greatest number of deaths of any sort of climate-related risk in the U.S. And as we recognize, particularly with increasingly aging population or folks who are immunocompromised in some way, or the young, these are folks that increasingly are widely recognized as sort of vulnerable to heat episodes, as well as all the infrastructure systems in which we use on a day-to-day basis to quote-unquote adapt to heat, maybe not in a positive way, but using our air conditioners, right? So what the city is particularly concerned about is this notion of how many heat waves. And this is the idea of a heat wave is defined by 3 days above 90 degrees Fahrenheit on a consecutive basis. This is something very specific to the city of New York. And what they're really concerned about are super heat waves. Those that last more than 3 days in a significant matter, maybe 6, 7, 8 days. And the reason why is that becomes, if you really want to get into the grist of all this, the HVAC systems. HVAC systems are pretty resilient things of themselves. They're pretty well engineered. They can handle sort of running 24/7, in a heat wave, 3, 4 days, maybe 5 days. But after 5, 6, 7 days, these systems start to break down because they're just not well engineered to sort of last that long, running 24/7. So these are the kinds of things that keep people up at night. And the other sort of other examples of things like how many days above 90 are we going to get over the course of an average year. And those numbers shift from about 18 for a given summer for the city of New York to upwards of 50 plus or 60, depending on which part of the distribution that you look at. And that was actually something that was highlighted in a press conference that was organized for Monday, basically saying that New York is going to have as many heat days as Birmingham, Alabama. So that was sort of the graphic illustration. But again, in terms of the science process, I'll tell you that they didn't. The city did not, confer with us, the scientists, about that, that analogy. We had talked about Charleston or other sort of more, coastal cities, but for some reason, somebody got excited about using Birmingham as the exemplar. So these are sort of the illustrations of how this process is played out, both in terms of the science and the interpretation. The other thing that we looked at is this issue of flood occurrences and how that frequent event will change. And again, too small to sort of highlight, but I'll step away from the mic for a moment. This line is showing you the 10-year flood zone. This one here is the 100, and this is the 500. So the idea of the 10 is like, an event that would occur, quote unquote, every 10 years, or 10 out of 100 years. So at any 1 year, the baseline is a 10%, right? This is the occurrence probability. By the 2050s, in sort of the higher sea level rise scenario example, there'll be almost a 50% chance of that event occurring every year. So if you think of those communities and areas, much of which are kind of in the very much at the water's edge, the marinas, the beach, the recreational areas, or maybe other sort of ecosystems within that intertidal zone, these are places that maybe occasionally get washover every 10 years. The dock gets washed out, that kind of thing. So we're saying under these kinds of scenarios, there's a 50% chance, 1 out of 2. It could happen every year. So it's a very dramatic sort of reinterpretation of the idea of occupancy of these sites. Now that 100-year flood zone, that's really, that middle line is really the important one with respect to a lot of insurance questions. If you own property in a flood zone, FEMA will say, well, you live in a coastal flood zone, 1%, you have to buy flood insurance, et cetera, et cetera. So the current rate is 1%. By the end of this decade, by the end of the 2050s, it could be a 5% chance, so 1 out of 20. And of course, the way that sort of plays out, if you're buying coastal property, this is what the city was interested in, and if you're buying a 30-year mortgage, the odds of this happening within the lifetime of your 30-year mortgage, actually, I wish I had the number with me. It's not on this data sheet, but I think it's like 60 to 70% or something like that. So if you're owning your property for the term of the mortgage, there's a pretty fair chance you get hit. And of course, that more catastrophic event, now the 500-year flood zone, that's really a very difficult thing to estimate. It's really a statistical manipulation to create it. But even that, the chance is 0.2%, right, any particular year. But that chance will more than triple to about 0.7% by the 2050s for that large-scale catastrophic one. This is some of the illustration of some of those extreme events and try to giving sort of qualitative measures that I mentioned to you. Again, within the report, there are a lot of interesting references that you might want to sort of tag back through. But it's really, I think, in most cases, well, in all cases, the directionality from the 2009 report indicate that things have gotten a little bit worse. Not dramatically. I don't want to be alarmist by any means, but in some cases in all cases we see a slight acceleration of the process. Now, one of the things that was very powerful in this whole effort was this idea of creating graphics, and particularly maps. This is one of the things that the city was very much interested in. The special initiative report really spoke to that question of mapping. And this was 2 of the maps that we produced. And what it tried to illustrate was this notion of what's the existing 1% flood zone, that FEMA designated high-risk area that you need insurance for, and how will that inundation area change with sea level rise? So if we look at this one here, actually let's look at the upper left. That's the 1% with respect to the 100-year. This is the 500-year flood, which I'm not as excited about that, but statistically it's much more difficult to define. But the upper left was the graphic that we produced, which actually was elements of that, which I'll show you in a moment, was the very first thing that Bloomberg presented yesterday. So as a scientist, it was sort of exciting to see, hey, you know, it was taken up, and it was the very first thing that he presented in his press conference, which I'll again show you in a moment. But the illustration here, the purple was the area of the 1% flood zone as it's currently been designated by Federal Emergency Management Agency. The red are those additional areas that will be flooded in the 2020s with, you know, with the additional sea level rise, and the yellow would be those additional areas, those additional inland areas that would be flooded by the 2050s with the same storm event. Okay. Now I'll sort of toggle over to, this is the stuff, now I can be like good old Mike Bloomberg yesterday. You know, he's got this great way of talking, you know, sort of, I know he's originally from New England and all that kind of stuff, you know, he's still a little bit of that Boston in him. But anyway, he does this sort of thing. But this is these are the slides he used. So, and there's been a really interesting shift that's happened here. In 1983 was the last time FEMA had designated the 1% flood zone. And then the city, in the last couple of years, has recognized that these need to be updated, right? These need to be sort of made more detailed. And so FEMA was in a process of updating it when Sandy hit. So what you'll see as you scroll through is what the revised FEMA flood map looks like, and then on top of that is additional with sea level rise. So this sort of seamless play out is really the powerful story that Bloomberg wanted to try to get across. All right, so this is what, you know, in October 1st, October 28th of 2012, this is what was considered the 1% flood zone for the city of New York. This is what it is as of June. These data were released June 10th, so Monday. These data were released officially by FEMA. So that's the revised 1% flood zone for FEMA. This is what the inundation area will be with sea level rise projected by 2020 for that same, in that same zone. And that would be that same event by 2050. And so good old Mike was toggling back and forth a few times for effect. Okay, so this is it. That's 83, 2013, 2020s, 2050s. All right, so that's sort of the power story that got behind the development of the SIRR. I'm going to toggle over to that in a moment. One of the things that sort of came out of the NPCC was this notion of creating a flexible adaptation. So this is really an effort that the city has taken up in some ways. This is coming back from our work from 2009 and actually work that was originally done in London. But basically the idea that you need to incorporate planning such that you recognize that you're in a dynamic situation. And if you don't do anything, you're going to exceed that acceptable risk level, which is the this sort of wavy line. This is obviously very much in the abstract. This, if you don't do anything, if you start to make it flexible, you can create and bring forward innovation that will keep you below that line. Okay. I don't want to sort of belabor this. This is sort of the superstructure of the NPCC. We'll come back to that if possible. There's been a lot of efforts looking at this question of resiliency within the city. A lot of reports have been produced. These are a couple particularly looking at climate change adaptation issues, and that a number of actions that have taken place leading up to Sandy. Just before Sandy, in the last couple of years, Plan NYC, which was a principal planning document for long-term planning and sustainability, released a second edition, right? Plan NYC 2.0, and resilience was very much the benchmark that was included. The word resilience was not even present when Plan NYC was first produced in 2007. The 2011 version had it like about 140 times referenced as a word, right? So it really kind of moved forward on the political agenda. What happened after Hurricane Sandy is that Bloomberg brought forward the special initiative on rebuilding and resiliency, and basically it was trying to address these three questions. what happened during and after Hurricane Sandy, what is the likely risk to New York as climate changes and the threat of future and severe weather increases, and what to do in coastal neighborhoods and citywide infrastructure. Right? So this was something he brought forward in an address in December of 2012, and the report was released yesterday, 430 pages or so, a massive volume, right? And available on websites and so forth to take a look at. The superstructure of it all, again, a little small, but this climate analysis, basically, to kind of go under the hood a little bit, that climate risk information report that I mentioned, and I've gone through some of the slides, that was then embedded into the report in that chapter. So it was translated from science into sort of a more publicly accessible treatment in this chapter here, which is chapter 2 of the document. But then there were all these other documents that provide the elements for what the action plan is and how to move forward. And it's a very broad-ranging sort of set of issues. And really, as I think about the presentation yesterday and some of the press, it's really still not, looking at all the various aspects of the plan that is now being stated to create this more resilient city. So it ranges from coastal protection all the way down through insurance, utilities, fuels, healthcare, telecommunications. These are individual chapters of this report. And then, of course, there's a section on these communities that were hard hit as part of Hurricane Sandy as well. Each of these components, as with previous NYC documents, Plan NYC documents, have a set of metrics, of achievement, and then means to achieve those, and then potential funding sources. Now, the principal funding source for all this, as you probably know, why this whole process took place, again, was a recognition that the City of New York was going to get billions of dollars in federal rebuilding aid. And this was basically the bucket that was built, to create a mechanism to take that money and distribute it out in a set of very strategic and sort of thought-out methods across a set of elements and also a set of communities. Okay. Now, a lot of what we've heard, in the initial press thing, involves a lot of there's a lot of sort of technical components to this, as well as a lot of infrastructure. It was very much focused on how do we ensure resilience, meaning tough, i.e. New York, in the face of climate change. And so, of course, there's been some discussion about creating this huge barrier across here, or in other locations across the Verrazano. Bloomberg is not embracing that idea, although one of the principal mayoral candidates, Christine Quinn, has come out months ago and at least recognizing that we should study this kind of question. What the Bloomberg plan, as he outlined yesterday, was a set of strategic, targeted infrastructure elements, both that have gray or hard qualities to them, more traditional things like levees and barriers, and some green qualities as well, like beach dunes and so forth. And probably the largest one, which is sort of connected to some of my other work, is he wants to build a storm surge barrier, or proposal to build a storm surge barrier here in Rockaway Inlet to prevent storm surge from going up into Jamaica Bay and affecting the communities. So I'll just sort of toggle through some of the illustrations, some of the logic that was used to sort of present some of the arguments that was seen yesterday. So you can imagine you're in Brooklyn. I'm bringing Brooklyn to you from yesterday. These are some of the images that were gone through. What was presented was this notion that if you look at various beach areas in Brooklyn and Queens, that if you had areas where there was well-established dunes, where there weren't well-established dunes, you saw a lot of damage. And then areas where there was established dune fields, there was relatively little damage. Now, this is very much sort of just anecdotal and so forth, but there's been a large, long, and rich history about how do you use these features, such as dunes and et cetera, to protect against shoreline erosion and damage. So this is sort of some of the logic that was presented. And that there's a whole range of initiatives that could be placed to promote different kinds of opportunities. The Seaport City was an idea of integrating and building a new residential area off the East River that would be protected from storm surge through new and efficient engineering. And then, of course, other ways of like this boardwalk, which would be elevated, so it would serve not only as a barrier to storm surge, but also an amenity value. And there are a lot of other sort of examples, sort of integrating amenity access into protection and resilience. So the idea of like connecting Red Hook, which was an isolated community in the response to Hurricane Sandy, more directly to other parts of the city through a ferry service. Of course, there's more traditional things, but also innovative about building sort of flood protection barriers that could go up very quickly in the onset of a storm, such as something like this. And then other sort of features that involve gates and other barriers, not unlike some of the designs and elements we've seen in the Netherlands and other countries. And then sort of levees and other sort of elements that have natural quality that could serve ecosystem, as well as storm protection devices or storm protection opportunities. Okay, so there was that sort of broad swath of different sorts of approaches that were brought forward. I think it's still sort of, there's still that question of how to bring forward all the various sort of potential with respect to this resiliency effort and sort of ongoing efforts. You know, if you look at the plan itself, it really incorporated a range of different approaches, although for the most part it was in this area, so the hard or gray infrastructure. In general, they moved from not so much the large scale, but to the smaller scale, the targeted stuff. There was a little bit of green or soft infrastructure, some of the levees, some of the blue blue infrastructure that would promote stormwater control, but again, relatively small scale rather than large scale. There wasn't really a lot of, very much strident was the idea we're not retreating from the coast or anything related to that, and the idea that we need to create opportunities for people to gain access to insurance, but we want to allow people to sort of live in communities as they are present. That was at least the issues that were brought forward. What I want to do is just end off with a couple of sort of reflections on this. There's some other little bits I'll sort of clip over just in deference to time and maybe come back to as if we have more time with the questioning. So one of the things, some of the issues that sort of came up with respect to challenges and opportunities, I think one of the things that was very powerful here is that there was a lot of the climate science data were already present, based on previous work. So as the city was mobilizing, it could work from that base. Obviously, New York is sort of special and unique in some qualities because it has that extensive base. But even much smaller cities are now sort of mobilizing, creating some base of information. There was also a rapid assessment strategy to figure out what the impacts were, what the vulnerabilities, and created opportunities for increased resilience. There was also that sort of larger goal of resilience. The 2011 NYC plan had already stated that resilience was a kind of a key element. And this now 2000, this is really seen as NYC 3.0. Now resilience is even brought further to the fore. Another thing that happened was a tremendous amount of interagency cooperation, not only within city agencies, but between city-state and between city-state and federal entities, and particularly between the city and the federal government. There's been a lot of cross-communication going on and a lot of excitement as to how to promote that sort of long-term cooperation with respect to more flexible adaptation to climate change. There's also been a recognition that we need to think about other metrics and measures for hazard and risk description. We have the 1% flood zone, but this is increasingly something that's dynamic and changing with sea level rise. Is it still the best measure? Are there other measures that have become relevant? One of the things that we promoted within the NPCC is an opportunity to sort of look at the climate protection levels and recognize that the city, as with any city, has created an extensive series of codes, standards, and regulations to protect people and property from climate risk. We need to sort of think about how to update those with respect to climate change, make them dynamic as well. And there's a range of other sort of elements that sort of start to really become increasingly recognized. The system perspective becomes increasingly important, recognizing that if you tweak the system one way, it's going to have some effects in other locations. We have to sort of look at the whole. I mean, this is sort of cliche in some ways, and particularly within an academic setting such as this, the value of system thinking, but it's now starting to really have a meaningful place in the policy arena as well. And then with that, we need a sort of a better understanding and capacity to translate uncertainties and sort of unknowns with respect to the data and provide that as a mechanism for ever more informed decision making. And with that, another sort of particular issue of mine is this notion of how do we take advantage of these extreme events? I mean, climate change creates a condition of this chronic shift that we're now experiencing, punctuated by extreme events. And how can we use those extreme events as opportunities to push forward progressive policy? If some aspects of Plan NYC 2013 get moved forward, really what it's done in a sort of a little bit of a Trojan horse kind of way, it's really brought forward the issue of climate change very much, into the policy decision making. It really wasn't frontlined yesterday. It was sort of the background context that climate change is happening, and that this is forcing us to get into the details of how to make our city more resilient. And that was, so we could be in this moment of interesting change, but the issue is it's not just sea level rise. There's going to be a whole range of other sort of extreme events coming our way, whether it's heat stress or other kinds of droughts, et cetera, and how do we use this as an example to sort of push forward the policy window even further. I'm just going to end off with a couple of slides to sort of toggle through. I'm not going to go through them too much, but I just wanted to just leave on this one for a moment. One of the things that I've spoken about in other contexts is the idea that, it's interesting to look at cities as capacity to respond to challenges. And I think if we look back historically, cities have always been doing that by definition. Every city that exists today has had to meet and be successful with respect to the challenge of providing water for its citizens. Right? In some cases, we build fantastically extensive systems like Los Angeles and New York. So how do we sort of learn from those experiences, whether it's air quality or water quality, et cetera, and apply some of that understanding to climate change today? So I'm going to end off with this notion of whether or not how much different is climate change adaptation and the ongoing sort of response of cities to other similar or different from other activities that they've had to entertain in the past. And this is some illustration of some of my thinking on that. But I'll just sort of end off with, to leave some time for questions, is that Hurricane Sandy certainly has pushed forward this whole dialogue. And the question is, will we be successful where we were not really successful after Katrina? One of the legacies of Sandy is that we were able to integrate climate change science in a real meaningful way to a long-term strategy for protection against things like extreme events like hurricanes. Bloomberg put forward a statement that sort of related to that. I would say it's not perfect, but it's at least an interesting step forward. And I think that there are many challenges that lie ahead as to whether or not we can create this sort of in this notion of non-climate, the standard line is that we're in a moment of non-stationarity with respect to climate. The climate is dynamic. Can we also create a non-stationarity with respect to climate policy? Right? So that's sort of my last sort of thing to think about. Thanks.